So let's consider the following case. You have an unknown circuit element. The only thing you know about your circuit is it's got everything in series in it. And so you want to find out what's in your series circuit. So your series circuit is just a black box with two terminals. And you've got some unknown thing in here. The only thing you know is whatever is in there is in series. So you know that it could be a resistor, capacitor, or inductor. And so you want to figure this out and see what's going to happen. So first thing you do is you take your unknown circuit and what you do is you put it across a battery. So we'll say this is a 9-volt battery. And when you do this, you're going to put an ammeter in here, and you're going to measure that the current here is 0.576 amps. Okay, so you can have resistance, you can have capacitance, you can have inductance. You've ruled out capacitor because if this were a capacitor, once it's charged up, you would have zero current. So that means there's no capacitor in series. So this may be an RLC circuit, but it's got no C in it. So it's just an RL circuit. So at best, I mean, it may be just a resistor. So what you do is you want to find out what it is. So you are now going to connect it to your unknown circuit to a variable power supply. And so this variable power supply function generator has a frequency of 1.5 kilohertz. And it's got a voltage. The RMS voltage is going to be equal to 9 volts again. Now, if you do that, you put an ammeter in here and you see what happens, and now your ammeter reads 0.316 amps. Okay, well, this is now an AC circuit, so you know the current is going to be V over Z. So the Z is just going to be V over I. So the impedance is now going to be 120 volts divided by 0.316 amps. And so that turns out to be equal to 28.5 ohms. Okay, so, well, that's not the same as you got before, because before you got 15.6 ohms. So you know the resistance, you know from before the resistance is going to be 15.6 ohms, but the impedance is 28.5 ohms. So what that tells you is there's got to be something other than resistors in there. And that, I mean, the impedance is not the same as resistance, therefore you've got inductors or capacitors. Well, we know we do not have capacitors because if we had a capacitor, we would have gotten zero current in there. And so it's got to be an inductor. So what we've got is an RL circuit in here. So that means we have a resistor and we have an inductor. And so I want to find out what's the inductor. Well, we know that Z is square root of R squared plus XL minus XC squared. Okay, there is no XC because we said we can't have that, so that we do some algebra. Z squared equals R squared plus XL squared. XL is going to be the square root of Z squared minus R squared. Okay, so XL square root of 28.5 ohms squared minus 15.6 ohms squared. So XL is going to be equal to 23.9 ohms. Well, XL is 2 pi FL. So L is going to be XL over 2 pi F. So that will be equal to 23.9 ohms divided by 2 pi we said 1.5 kilohertz, so that's 1500 hertz. So L comes out to be 2.53 millihenries. So our unknown circuit here is going to be a resistor and a capacitor with a resistance of 15.6 ohms, and not a capacitor, but an inductor, and inductance of 2.53 millihenries. And so that's how we identified what our unknown circuit was. Now, if I had done the same thing and had zero, then that'd be a little bit different sort of thing. So that'll be our next unknown circuit.